Pavani. I have selected a GRF in NIT Varangal. My guide sponsored advised me to join in this workshop.
Good morning, everyone. I am Manoj Mishra. I am from IIT Mandi, and I am doing doctoral research at IIT. Thank you.
Hello, everyone. I am Brajesh. I am pursuing PhD in IIT Mandi, and I am in second year student.
Good morning, everyone. I'm the faculty of Vagdevi College of Engineering nearby this Varangal. Purnachandra.
Yeah, this is Dr. K. Prakash, Professor of Electrical Engineering, Vagdevi College of Engineering, and Principal of the same institution. Me joined here along with my scholar. I want to know some tips and advice from the workshops.
Hi everyone, I am Sharif, research scholar in NIT Varangal.
Hi everyone, good morning. I am Shankar, research scholar in NIT Varangal from EC department, and my DS member is Sir Uday Bhaskar.
Good morning everybody. My name is Madhavaram. I am faculty at BMS College of Engineering, Bangalore.
Good morning, everyone. I am K. Raju, JNTU Kukatpalli. I'm pursuing a PhD. My guide suggested to attend this program.
Whatever the things which are there in your mind is humble and kind enough to answer all your queries. Okay, and is having the vast experience in power system, power electronics, DSP programming, multi-level inverter, modulation techniques, okay, power system, HVDC, transmission, fax devices, and you can have, means like even he worked with the live projects in Denmark, he was there, and then Finland, Spain, France, Germany, and Canada is there, and vast experience, international exposure, and is very hardworking and kind enough, constantly works on the of subject. Yeah. So we'll get more information on him once the inaugural session commences. We'll have more topics and more about him. Yeah, some laboratory simulation-based experiments are there, madam.
Good morning, everyone. So, Director Sir is about to come for the inaugural of this event in few minutes.
A very good morning to all dignitaries, faculties and participants. I am Dharavat Anusha, Research Scholar, Electrical Engineering Department, NIT Warangal. It is indeed a privilege to welcome our esteemed dignitaries for the inaugural ceremony of a 10-day GIAN course on operation and control of power converters for integration of renewable energy sources into power grids. As we begin this significant occasion, may I have the honor of inviting our distinguished guests onto the dais. First and foremost, I take a great pleasure in inviting our esteemed leader, Director NIT Warangal, Professor Vidyadhar Subudhi sir, to kindly take their seat on dais. Please, sir. Thank you, sir. A round of applause, please. Next, we are honored to welcome Professor S. Srinivasa Rao sir, Dean International Relations and Alumni Affairs, whose guidance and support was crucial in conducting this GIAN course. Sir, please we welcome you to kindly join us on dais. Thank you, sir. Next, we are honored to welcome Professor Sonavani Shiri sir, Dean Research and Development, Next, it is our pleasure to invite Professor N.V. Srikanth sir, Head of the Electrical Engineering Department, under whose guidance this program has taken into shape. Sir, please join us onto the dais. Thank you, sir. Next, it is our privilege to invite our distinguished resource person, Professor Edris Porsmel sir, Associate Professor with the Department of Electrical Engineering and Automation and Head of the Renewable Energies for Power Sister Group at Aalto University, Finland, whose insights and expertise will enrich this course immensely. We request you to grace the dais, sir. Thank you, sir. A very special welcome to Professor Shailaja Kumari ma'am, Professor Electrical Engineering Department, whose support is invaluable for this course. Thank you, ma'am. I would like to invite Professor M. Uday Bhaskar sir, Course Coordinator, Associate Professor, Electrical Engineering Department, our Program Coordinator and driving force behind this successful organization of this program. Thank you, sir. With our esteemed dignitaries now on stage, we are set to begin this momentous occasion. Thank you for honoring us with your presence. Thank you, everyone. Now we will start this program with a welcome song. I would like to invite Lahari and Kaivalya to start a welcome song.
सुता तनया सदया गिरिराज 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 सुता तनया सुरनाथ मुखार्जित पादयुगा सुरनाथ मुखार्जित पादयुगा परिपालय मामि भराज मुखा सुरनाथ मुखार्जित पादयुगा परिपालय मामि भराज मुखा गिरिराज सुता तनया सदया गिरिराज सुता तनया सदया गिरिराज सुता तनया गणनाद परात् परशङ्कर गणनाद परात् परशङ्कर आगमवारिनिधि रजनीकर गणनाद परात् परशङ्कर आगमवारिनिधि रजनीकर फणिराज कंकण विघ्न निवारण शाम्भव श्री त्यागराजनुता फणिराज कंकण विघ्न निवारण शाम्भव श्री त्यागराजनुता गिरिराज सुता तनया सदया गिरिराज सुता तनया सदया गिरिराज सुता तनया सदया गिरिराज सुता तनया
Now I would like to invite dignitaries for the lighting of lamp. Thank you, sir. Thank you, everyone. Now I would like
वन्दे मातरम् वन्दे मातरम् सुजला सुफला मलयज शीतला सस्यश्यामला मातरम् वन्दे मातरम् शुभ्रज्योत्स्ना पुलकितयामिनी पुल्लकुसुमित द्रुमदलशोभिनी सुहासिनी सुमधुरभाषिणी सुखदां वरदां मातरं वन्दे मातरम् वन्दे मातरम्
Thank you, everyone. Now I would like to invite our program coordinator, Professor M. Uday Bhaskar sir, to give a brief about GIAN course. Thank you, sir.
Thank you. Thank you. Can you hear? Is it fine? Yeah. Okay. Yeah. First, thank you for inviting, for giving the overview on this GIAN program. So, first of all, respected dignitaries on the dais, Professor Vidyadhar Subudhi sir, Director NIT Warangal, Professor Edris Poresmal, Associate Professor, Aalto University, Finland, Dean, International Relations and Alumni Affairs, HOD of Electrical Engineering Department, Professor M. Shailaja Kumari Madam, Professor A.V. Giridhar, and of the dais, esteemed participants, faculty colleagues, technical and supporting staff, a very good morning to one and all. We are thankful to the IIT Hyderabad for accepting the course proposal on operation and control of power converters for integration of renewable energy sources into power grid. And also, I am honored to provide the overview of the GIAN course on operation and control of power converters for integration of renewable energy sources into power grids. The title has drawn an attention of the world. The present day, the world is experiencing global warming. Global warming is a global concern and it is increasing day by day. This is an international issue to address the global warming on world forums. To address the issue of the global warming, reduction of carbon footprint, net zero emissions, speakers have chosen the topic of global interest to disseminate the knowledge on renewable energy sources, its complexities, challenges, storage devices, hybrid energy storage system, special focus on batteries, supercapacitors, flywheel energy storage systems, pumped hydro energy storage systems, multi-level inverters and their modulation schemes for high power application, novel controllers, especially on model predictive control, DSP programming, and other platforms to the eminent and energetic participants of various categories of their interest in power system and power electronics arena. The response for the GIAN course is of overwhelming across India. The credit goes to the humble faculty, Professor Edris, an intelligent, constantly working person for all the time. Renewable energy is a growing component of electricity networks around the world due to its contribution to reduce the carbon footprint, long-term security, and expansion of energy access to new energy consumers in the developing world. However, the integration of large-scale renewable energy sources remains a challenges today. The stochastic behavior and variable output impose real-time balancing challenges in the power system, which makes necessary to increase the power reserves provided by conventional power station. Furthermore, distributed generation used to be connected to the power grid by means of power electronic converter whose operating principle has nothing to do with the synchronous nature of power grid. The lack of inertia of this kind of generator together with their odd transient dynamics gives rise to negative impacts on the power system operation and thereby hinders their integration into the power grid. Just the opposite what happens with the conventional synchronous generator. The main objectives of this GAN course, first to investigate the complexities of renewable energy integration into power system, to examine the challenges posed by stochastic energy sources and variable generation, to explore the role of power converters in connecting renewable energy sources into the grid, to understand the unique operating principle of power converters and their implications, to develop the strategies and control techniques to mitigate the negative impacts of distributed generators and power system stability, to understand the operation of power converters for hybrid energy storage system. The lectures, tutorials, and the topics are in line with the objectives of the course, starting from the history, challenges, opportunities, distributed energy technologies, its applications in power system network, HVDC transmission, facts, microgrids, smart grid, hybrid energy storage technologies, associated converters, and their mathematical modeling. In operation and control of grid-connected power converter, the topics of interest as Park and Clark transformations, general model analysis of grid-connected converter, dynamic model analysis. On this topic, Professor Edris is working extensively in an international scenario for a long time. Edris will take you to the depth on these topics. So, reference current calculation, simulation, hardware, fundamental results with developed prototype or hardware can be discussed. Participants will enrich and experience to have professional development in research and teaching arena of power converters for power systems. Predictive control model transformation and analysis, current control technique design will provide you a new awareness to the eminent participants. Emerging topics of grid forming operation mode, grid forming mode as a virtual synchronous generator, problem solving sessions on these topics make the participants more interesting. Model predictive control, based control power converters, based generator, voltage and current references for the proposed field reference trajectory strategy is an added flavor to the GAN course. FRT strategy results and discussion make the participants to the new era of research. This 10-day GAN course is designed to provide participants with the emerging topics in operation and control of power converter as a fundamental technology in the successful integration of renewable energy sources into modern power grids to meet the specified objective. And also, it addresses the key role of power converter in providing supportive functionalities and ancillary services to enhance the stability of the power grids. Okay. Throughout the course, the participants will explore the complex workings of power converters and gaining insights into the operation and control mechanism. Additionally, they will explore the key principles and the techniques necessary to harness the renewable energy sources effectively within modern power grid. Towards the end of this 10-day GAN course, participants will not only possess the deep understanding of power converter, but will also be equipped with the knowledge and skills needed to contribute to the successful transition toward the cleaner, more sustainable energy system. Thank you. Thank you once again. I heartily welcome all the participants for this GAN program. Thank you.
Thank you, sir. Now I would like to invite Professor Shailaja Kumari ma'am to give a brief introduction about the resource person.
Yeah, good morning everyone. Professor Vidyadhar Subudhi, Director, NIT Warangal, and the guest of today, Professor Idris Forsman, and Professor S. Srinivas Rao, Dean, IRAA, and my colleague, Head of the department, Professor N.V. Shrikant, Dr. Uday Bhaskar, the course coordinator, and all my dear colleagues, friends, and all the participants. A very good morning to you all. Today I'm privileged to introduce the guest of the day, and who is the expert for all the 10 days for this GIAN course on operation and control of power converters for integration of renewable energy sources into power grids. So Professor Idris is an associate professor with the Department of Electrical Engineering and Automation and the head of Renewable Energies for Power Systems Group at Aalto University in Finland. He has held significant roles in esteemed institutions worldwide, including Senior Researcher for Control of Power Converters in Intelligent Power Plants at Ischia Institute of Technology, France, and a Senior Researcher at Ebongia Research, Sevilla, Spain, Associate Professor in Energy Technology Engineering at the University of Southern Denmark, then postdoctoral researcher at the University of Waterloo, Canada, and PhD research fellow at the Center of Technology Innovation in Static Converters and Drives at Technical University of Catalonia, Barcelona, Spain. So Dr. Idris' research expertise lies in the operation and control of power electronics in power systems, the integration of renewable energy sources into the power grids, microgrid operation and control, and the modeling and development of hybrid energy storage systems primarily reliant on green hydrogen. He has authored more than 190 scientific publications in journals, conferences, and book chapters. Dr. Idris is a senior member of IEEE and serves as associate editor for prestigious journals such as IEEE Systems Journal, IET Generation, Transmission and Distribution, IET Renewable Power Generation. Additionally, he contributes to the guest editorial board of IEEE Transactions on Power Electronics. So thank you, sir. We are really thankful to Dr. Idris for being here with us for all these 10 days and sharing his knowledge with all the participants of the GIAN course. So thank you.
Thank you so much, ma'am. Now I would like to invite Head of the Department, Electrical Engineering Department, Professor N.V. Shrikant sir, to give address about the Electrical Engineering Department.
Respected Professor Idris for Ismail, Aalto University, Finland, respected our beloved Director Sir, Professor Vidyadhar Subudhi, Professor S. Srinivas Rao, Dean IR and EA, Professor Sailaja Kumari for Department, my colleagues, participants, ladies and gentlemen, a very good morning to all of you. It is a privilege to introduce about our department to you all on this inaugural function of this GIAN course on operation and control of power converters for integration of renewable energy sources into power grids. The Department of Electrical Engineering is one of the oldest departments of Regional Engineering College, Warangal. Now it's a National Institute of Technology, Warangal. It was established during 1959. The department is growing, actively engaged in teaching and research in diverse fields of electrical engineering. At present, around 32 faculty members are working in the department. Faculty having expertise in various fields of electrical engineering in power systems, deregulation, power electronic converters, drive systems, power systems, smart electric grid, control and automation, and control of special machines, renewable energy systems, converters for renewable energy systems, microgrids, multi-level inverters, open and winding induction motor, applications of power electronics to power quality, and DSC, control drives, relay coordination, state estimation, applications of AI techniques in power engineering and electrical engineering by and large. Department of Electrical Engineering offers BTech in Electrical and Electronics Engineering, MTech in Power Electronics and Drives, Power Systems Engineering, Smart Electric Grid, and MTech in Control and Automation. And we also offer PhD in all the major fields of electrical engineering specializations. We also have self-financed MTech programs, PG diploma and PhD have been started from the year 21-22. We have at present 136 UG students admitted through JEE in BTech and around 100 students through GATE in MTech, all programs of our department, and around 100 research scholars are working towards their PhD in our department. And we have also have 100 research projects sponsored by various agencies like MOE, MHRD, Imprint Spark, DST, CPRI, SERB, etc. executed to a tune of around 650 lakhs. And we have also have recently a sanctioned project DST FIST, more than 1 crore, and around 9 to 10 research scholars are working towards their execution of these projects. Department has state-of-art equipment such as programmable DC power supplies, programmable solar simulators, high-end mixed signal oscilloscopes, digital signal oscilloscopes, multi-level inverters, lab view software, hardware kits, and we have Opel RT, rapid prototyping systems, DSP labs and all. We also have a full-fledged smart electric grid lab equipped with all the state-of-the-art equipment and sponsored by Hitachi Energy India Limited. And then most of the equipment are sponsored to MHRD TechCube and all various sponsored research agencies. The department has a strong industry interaction and has been involved in constantly handling various consultancy projects for various industries and lift irrigation projects of Government of Telangana and Andhra Pradesh. The department has an MOU with Central Power Research Institute, Bangalore, ABB Power Product Systems India Limited, Bangalore, Power Grid Corporation of India Limited, POSOCO, Power System Operation Corporation, known as Grid India, now with Hitachi Energy India Limited. We have also have collaborative research projects with them. Department also participates in the student exchange program with IITs. Now we also have technical support through electrical engineering societies, IEEE student branch, and women engineering. Student mentorship, industry visits, industry lecture series through electrical engineering society and are in the curriculum, and they are executed in our department. Outreach activities, prestigious faculty development program and training programs have sanctioned to the department, sponsored by the Government of India under various prestigious schemes like GIAN, Atal, Spark, E&ICT, MIT, TLC, NIT, etc. And then we also have self-financed STTPs undertaken by the faculty of the department, through which our department faculty are contributing to improve technical education in various domains of electrical engineering community in the region and across the country as well. Apart from this, department faculty actively contributing towards various academic and research activities to the community of technical education. MTech SCG program, in fact, all our MTech and BTech programs are going on very well with an overall placement record crossing 90%, and MTech SCG program really is taking a lead in this regard. The department having good placement record. Also, we have our alumni placed in various positions in Indian Administrative Services, IES, and CEOs of multinational companies. With this brief about the department, I welcome all the participants to this 10-day GIAN course on operation control of power converters for integration of renewable energy systems into power grids. Thank you, one and all. Thank you.
Thank you, sir. Now I would like to invite our beloved director to address the gathering.
So very good morning to all. So I'm indeed very, very happy to see many young delegates with very cheering, smiling faces. So I believe that begins the 10 days program, the GIAN program organized by the department. So I join with the department to welcome Professor Edris from Aalto University, Finland, and which is a beautiful country in terms of its very, very specialized education system, if I am correct. Because many people across the world are very fascinated to go to Finland, where is a tremendous impact in the industry and academia connect. I believe Finland the worth example to mention here in this aspect. So I once again congratulate the department to have him here, and also thank the coordinator, Professor Uday Bhaskar, who has chosen a right topic for this GIAN program. And I also thank the Madam Saileja and the Professor Shrikant to be here, along with Professor Srinivas Rao. All of them are electrical, including the Dean alumni, including the director as well. So, so it's a very distinct, coincidence. And incidentally, this is one of my research area. And so therefore I am very happy to be here to listen something new and to be with the 10 days program as a student. But I don't have the opportunity to do that. But nevertheless, I will definitely discuss with Professor Uday about the lecture note, what is being delivered. Okay? And to me it appears, if we sit, if you teach only, nothing will happen. And there is always a kind of debate between the industry and the academia. The industry engineers have a mindset that we have a practical bent of mind, and the academia has a theoretical bent of mind, and there is a wide gap between them. If I give a simple example, if you ask an industry to apply a model predictive control, or maybe a like a sliding mode control, or maybe a backstepping control, so the answer is outright no. Why is it? Because the plant is running several years without any difficulty. Why to make a change? Why to take a risk? So therefore, the industry is more interested to not come out from the comfort zone of sacrificing the popularity of the PID, the three-term controller. Never mind whatever you convince them, they are not happy to accept the same. But this is the role of the academia today. If you go on applying the same PID control, if you go on applying the same manufacturing technology, you will be same in the pre-civilization age, and you will not progress further. So therefore, the change is inevitable. And how that change will come? That change will come through the research and through the deep penetration of the academia into industry. How is it? Like if I give an example, the silicon or germanium semiconductor materials for the power electronic devices to have it for the power conversion at different levels, then over the years it will go on. But if you read today, there are two important milestones have been reached. One is the silicon carbide and germanium arsenide. These are, the number of the kind of the advantages of these two semiconductor new technology are coming, to which will make a paradigm shift in the converter design. And today, whatever we are looking that the the supplementing the energy through the renewables, to the major achievement is to reduce the carbon footprint. And at the same time, we can augment your power requirement through the renewables. But what makes it more comfortable or more achievable? It is achievable because many aspects, not only the electrical engineers, every engineer has a role to play. A physicist has a role to play as well. That means till from the conversion of the photovoltaic, conversion efficiency to range, new materials to come in, and also to the new kind of power electronic devices for converting the power levels from one to the higher level or the voltage levels. That makes the the real renewable energy, harnessing it in more efficient manner. And if you see the grid connect, the integration between if you take two systems like the conventional power system and the renewable energy system, a lot of challenge in renewable energy system. The grid codes IEEE 1547 or IEEE 519, if you look at it, the stringent requirement is for the renewable energies. It's not the same, the THD, percentage of THD, or even the different order of the harmonics. What is the order? If you see the renewable ones, more stringent than the conventional power system. So therefore, we have a big role to play. The electrical engineers have a big role to play to really make the nation to make an impact to resolve the issue of the national or international cause of the carbon footprints. And when you talk about the electric vehicles, just by connecting an electric vehicle to the grid is not adequate achievement you can have. You need to have the augmentation of the renewables to the grid, and thereby you have the more benefit of getting this pollution, control, so far the carbon is emission. So therefore, this operation and the control aspect of the power converters to achieve efficient the grid integration and the efficient way of operating the same is quite challenging. And I believe if you look at the renewable energy, in particular the electrical engineers are primarily interested in three renewable aspects. One is the photovoltaic system, the other was the wind energy conversion system, and the fuel cell systems. So all of them, they require basically any power converter to be integrated. So maybe, then when you say about a power converter, then there lies also the control, because without a efficient control you cannot operate the power converters. So when you say about a power converter, obviously you need to have some kind of computing platform to really sense the data and execute the same with a very, very fast rate of sampling. So therefore many aspects are involved here. So I believe the course is very interesting, and the 10 days is quite, you don't feel that its span is quite big. I believe if you really take more interest, a lot of good thing can be achieved. And not only the listening in the classroom to really see that how best a converter can be used, and where the implement a control and to connect I think somebody mentioned, I think head has mentioned the simulators. So even though you don't have a panel there, photovoltaic panel there, you can have a simulator to see that the pattern of the insolation, how it affect, how the the kind of control can take care of it. So the course is very interesting, and please believe me that the country is moving many directions. If you say the sustainable goals, the 17 goals, one of the mandate is this energy, sustainable energy. So therefore the electrical engineers have big role to play for the meeting the sustainable goal challenges. And no matter whether you are young, old, or middle age, it doesn't matter, you have a lot of things to contribute. And therefore it is the easiest opportunity for you to participate in this GIAN program, and I must thank the initiative of the government to connect with the international academia to bring them here to this room and to discuss more on this topic and take it forward. And I believe your participation, not only this 10 days and beyond, will be meaningful to you and to the NIT Warangal as well. So I believe NIT Warangal is a forerunner in terms of its GIAN programs and SPARK programs, and it will be a legacy that NIT Warangal would definitely make a mark in contributing to resolve the national or international issues in whatever manner to come in the near future. And I believe you take this opportunity to connect with the faculty over here, to go around the lab, to see how best you can get the advantage of being connected, either to pursue a PhD or to collaborate with submitting a joint proposal or any form you wish to have. So please spend the time, and I believe your time of spending in this room and beyond, in the classroom, beyond the the laboratories, and your stay in the campus would be very, very fruitful and enjoyable and meaningful. Wish this program to a great success. Thank you very much.
Thank you, sir. Now I would like to invite our Dean IRAA, Professor S. Srinivas Rao, sir, to address the gathering.
invocation song by one student on this auspicious day. Today is Basanta Panchami is celebrated in this state. So respected Director Professor Vidyadhar Subodhi, foreign expert, Edris, Professor in Department of Electrical and Automation Engineering, Aalto University, Finland, Head of the Department Professor N.V. Srikanth, and my department faculty colleagues and retired and senior Professor M. Saidulu has shown interest to learn the state of art, the technologies, and Professor Amba Prasad, Mechanical Department, he has shown interest to know how these solar panels are connected to grid. And my dear participants and other faculty members, research scholars and students of the NIT Warangal, and warm welcome to all of you. So myself, I am Professor Srinivas Rao, Department of Electrical Engineering. I am looking after Dean International Relations and Alumni Affairs. So our office looks after the alumni affairs as well as international relations. We are many of you be knowing very well this one this REC Warangal, now called NIT Warangal, is the first institution of its kind. It was started in 1959 and first batch came out in 1964. At that time 5 years duration. They have celebrated very recently dynamic jubilee celebrations. And we are well connected with 42,000 alumni through our alumni website, and we are observing their accomplishments, get-togethers and achievements we are posting in this alumni website, and at the same time we are involving them for the development of the institute, and we hope their encouragement and support will be further and further extended for development of the institute under our dynamic leadership of Director Vidyadhar Subodhi. Regarding international relations, we are looking after the international relations, particularly to the Government of India sponsored projects like GIAN, Spark, MITAS, DAD, Heritage, etc. Along with that, we are approaching the various foreign universities and institutions for getting research collaboration, faculty exchange, as well as student exchange program under the dynamic leadership of our Director Professor Vidyadhar Subodhi. In the recent past, so many courses were conducted under GIAN and Spark program, and many faculty visited and enlightened the participants who came from different parts of the country, as well as faculty of the particular domain in the institute, as well as research scholars. So in the past 40-50 days, this institution is with full of international exposure. So we thank the Government of India for providing such a nice facility for bringing foreign faculty to India and making interaction with us, so that we all will be getting enriched and state-of-art technologies all are getting exposed. So regarding GIAN program, this was started in 2015, Global Initiative for Academic Networking, initiated by Government of India, and started from IIT Kharagpur. Phase 1, Phase 2, Phase 3 programs were successfully completed, and now GIAN Phase 4 program is running. This is monitored by IIT Hyderabad under the leadership of their director and national coordinator Anil Agarwal at IIT Hyderabad. And till now, all these GIAN courses, we got total 106 courses were sanctioned to us as a total, and fourth phase is going on, and we may be expecting some more GIAN courses also in the fourth phase, and fifth phase will be getting initiated very soon by IIT Hyderabad. You can visit IIT Hyderabad GIAN website as well as our institute website for getting the for knowing about the GIAN and Spark courses, so that you can encourage your friends, colleagues and other people to attend these GIAN courses and get exposed to the foreign professors. In this GIAN Phase 4 program, Electronics and Communication Department got 6 programs, and Electrical and Electronics got 7, and Mechanical Engineering 4, Civil Engineering 3, Computer Science 1, Mathematics 1, Physics Department 1. So total 23 courses were sanctioned. And we are almost, this is the 12th course we are running. Another 11 courses are due to be conducted within 2-3 months. These courses also will be conducted. We try to see our institute website and encourage the particular department, faculty, research scholars, etc., so that they can apply and come here and interact with the foreign professors. regarding this course on power converters, power integration to the grids. This is a 10-day program. It is very much essential nowadays. We all know that there are no conventional power generation stations are going to come. For example, thermal power plant, if they are not giving throughout the world, as long as my knowledge is concerned, throughout the world they are not giving any new thermal power plants. Whichever plant got its life period is completed, same capacity plants only they are allowing to establish. So in that process, to maintain greenhouse, to limit the greenhouse gases, and also solar photovoltaic systems are becoming very popular compared to wind energy stations also, because gigawatts of power can be generated within 2 to 3 months. So solar panels can be purchased and assembled, and inverter can be connected, it can be interfaced to the grid. But there are some challenges. So all those challenges means we know that power electronic devices as well as converters are non-linear in nature. So they, along with the generation of the power, they also inject harmonics. The total harmonic distortion must be within the limits. As per the IEEE and IEC standards, we are supposed to control the converter by applying advanced techniques, so that power system will be stable and will get a pure sinusoidal voltage with 120 degrees displacement, and each phase will have a 50 Hz frequency. Those are the challenges faced by these solar photovoltaic systems. So by attending this 10-day program, definitely you will be getting exposed to different type of challenges, control techniques and controllers, control schemes, their simulation, modeling, as well as the implementation of those things with real-time platforms, with the expertise from our foreign professor, Professor Edris. So I wish all the best to all the participants who will be. This 10-day program, it is not a simple program. 10 days program means we will be getting a lot of knowledge and information. So definitely we will be getting more and more exposure, and this knowledge can be definitely extended to the research projects and applying for any funding agencies, as well as guiding the research scholars, MTech students effectively and efficiently. Wish you all the best to all the participants who have shown interest to come and attend physically for this program. And GIAN Force is having a special feature that compared to GIAN Phase 1, Phase 2, Phase 3, in Phase 4, the attendance will be has to be uploaded daily to the local coordinator they are monitoring from IIT Hyderabad. At the same time, program has to be webcasted as well as recorded. The purpose of this GIAN 4 course is it has to reach as many as possible throughout the country as well as throughout the world to many students, faculty, as well as research scholars. You can also, the coordinator might have shared the web link to you. You can share that link to your friends as well as faculty colleagues and other relevant people, so that they can also watch this program. So IIT Hyderabad, the national coordinator, is insisting on this web link should reach as far as possible to the maximum number of the relevant people, so that they will get enriched with the subject knowledge. And the purpose of calling the foreign faculty will be 100% fulfilled. For that, all of your cooperation and coordination is required to spread this information to everybody. Wish you all the best to the coordinator as well as this program. And I wish my department, whole department, all the best for successful completion of this course. So I thank our director for giving nice information about the course also. He also belongs to our department. He already told under his guidance department is further and further progressing in a highly accelerated mode. Thank you one and all.
Thank you, sir. Now I would like to invite our international faculty and resource person, Professor Edris Posmal, sir, to address the gathering.
I don't talk about the now about the university. It's not needed. So I can. Okay. Yeah. Good morning, ladies and gentlemen, it's really a pleasure for me to be here, and thanks for NIT for inviting me, and also for this nice hospitality. India is a great country, and I was always interested to visit. So I'm not going to talk too much. We have 2 weeks to know each other more, so generally say a little bit about the who I am and from where. And a little bit about the Aalto University. So as my colleague also mentioned, my name is Idris Pur Ismail. I'm a professor of renewable energies for power system from the Department of Electrical Engineering and Automation at Aalto University in Finland. So Aalto University is a public university merged with 3 leading Finnish university in 2010. So we have actually 6 schools. So the university is a combination of students, staff, and also professors. So totally we are 20,000 and close to 14,000 students, 4,900 staff. Like we consider PhD student, postdoc, and other researchers, and we have 413 professors. So in Finland, the number of the professors are always constant, so the input and output depended to how many professors retired and how many of them also get the position. So the rank of the university is first in Finland and is 113 in based on QS World ranking. So we have also different ranking, but we refer basically to QS. So we have 6 different actually school, and a School of Art, Design and Architects, a School of Business, a School of Chemical Engineering, a School of Electrical Engineering, a School of Engineering, and a School of Science. So the rank of electrical engineering is normally based on 100 to 125. Last year was 113. 104 in electrical engineering, and we are 19th in telecommunication engineering based on QS ranking. So our other school like art and design get the rank 8 in the world, and other architect and building environment is 39. So we have an excellent, diverse, actually, university combination of the lots of actually national and international students. So the number of actually the share of bachelor students are from international is 9%, and the reason is that the bachelor is in Finnish language, second hardest language in the world. So it is very clear that why we have less bachelor students, but 30% of students in master level are also international, mainly non-European students, and 42 are also in PhD level. So in Department of Electrical Engineering, we have 700 personnel and 2,270 students. 55% of the students are international, and 90% of them are women, and you know that it is not that much interesting topic for females. But we are trying to increase actually diversity by adding more females in our program. So I'm not going to talk too much about our department. So just briefly say that, you know, we have three major, but if major is combination of different research topic. So head of the major is Professor Yurmakura, and we are working in power system and energy conversion. So when we are talking about this, we have variety of the topic, and in each topic we have a head. And we have control and robotic automation system and health technology. So we have an excellent research facility, and if later you're interested, we can discuss more about that, how we can actually collaborate together and maximize this benefit by interacting between the NIT and Aalto University. So this is probably just a sample of our lab. So Dr. Ferdowsha Ahmed, originally from IIT Delhi, if I'm not wrong, and from Martin is also from France. So we have actually excellent collaboration with the, we have excellent resources from Indian University, and we are really proud of this one. And this is actually one power system and energy conversion research field. We have 9 research group. So the group renewable energy is an interfacing group between power electronic and power system. We don't actually design converter. We use the converter for solving problem in power system. So because of the limitation, I'm not going to talk too much. Actually, my presentation was for 15 minutes, but probably we can actually discuss later. I can continue? Oh. Okay, yes, okay. So I'm really happy to be here, and one thing is that is excellent that we have a new generation. You're responsible for the future of the India. Yeah, thank you.
Thank you, sir. Thank you so much. Now, I would like to request faculty to facilitate Professor Idris Porcel, sir. Felicitate. Yes. Thank you, everyone. Thank you, everyone. Now I would like to invite Professor A.V. Giridhar, sir, to give vote of thanks.
Good morning, all. It's my privilege to propose vote of thanks for this GIAN course on operation and control of power converters for integration of renewable energy sources into power grids. First of all, my heartful thankful to Professor Vidyadhar Subuddhi, Director NIT Warangal, who has vision of uplifting our institute in different dimensions and motivate and support us to do the engineering and technological research and development activities, and we are thankful for sir. And we are thankful for our Dean, International Relations and Alumni Affairs, Professor S. Srinivas Rao sir, for his constant support and providing our guidelines for smooth conduction of the GIAN course. We are thankful for you, sir. And we are thankful for Dean Research and Development, Professor Shri Sonavani, for his kind support for conduction of the GIAN course. Our big thankful for our department head, Professor N.V. Srikant sir, for his constant encouragement and support for conducting this GIAN course. And we are very privileged and thankful for Professor Edris, International Faculty, for the GIAN course, who is from Department of Electrical Engineering and Automation, and also head of Renewable Energy of Power Systems Group of Aalto University, Finland. And we will be getting the challenges in this area, and mutually we will be having interactions, and we will be going to get benefit out of this GIAN course. And also we are thankful for supporting staff from Dean IRAA and also SRIC office for their support for the smooth conduction of this GIAN course. And also we are thankful for our research scholars, volunteers in organizing the GIAN course. And also we are very thankful for our participants who have come across our country and getting knowledge from these and also to do research in this area. And also, since we have all the different aspects, students, faculty and senior faculty also there, so there will be much more interaction, and everyone will be going to get much benefit of this course. And also we are thankful for our senior faculty members and also our faculties who has graced this occasion. We are thankful for you, sir. Thank you very much.
Thank you so much, sir. Now I would like to request everyone to stand for national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, everyone. Now it's time for a group photo session. Everyone, please join us on dais.
comfortable. We don't have big boss here. Yeah, so we can make a little bit more friendly discussion together. And I was not that much familiar with the Indian formality. So I came here like a casual way, say hello to everyone. I had a bad experience. I remember one time I was a speaker somewhere in the conference. Then I went very formal with coat and tie, everything. So then when I reached there, 50% of the people had the short. Yeah, so weather was very warm. And then I said, okay, look. And nobody with coat. So, but thank you very much. It is, you have a very strong, rich culture, and hopefully, yeah, it was my fault probably. Anyway, so I'm going to start again to talk about who am I, and then from where I came here, so probably you can get some idea that if you are interested later, collaborate with our university, or partially you do some parts of your study in Europe or also, you get some idea about that one. So, I'm just jumping from this part and again get back to this presentation file about the Aalto University. Is a Finnish university located in Helsinki. Helsinki, actually, they have a campus in Espoo. Espoo is a small city, but is completely part of the Helsinki. Then, if you are going to reach the downtown of the Helsinki, we have a metro inside of the campus, which it takes 4 or 5 actually a stop. You reach the downtown of the Helsinki. So it is not very big. It's not somehow. It's not too much crowd. So I can say that 50% of the time when you go to the metro, you can be probably only person in the metro. Not that much bad, but it can happen. Anyway, so everything is different. Not going to say that good or bad. So it's a little bit different. The weather is really cold, but it doesn't provide any problem for you. Easily you can actually jump to the public transportation and go front of your home. And the system is very good, and we have a very good support for international students. So if something happening, you have 100% support from university. I can say that I never seen someone from international actually community to join our university without financial support. So is also this type of possibility. Sometimes, I mean, we have this master degree that you get the scholarship, but the scholarship is like tuition fee is waived, and you have some. It's not too much, but is enough for support this life cost. And I can say that 100% of the students, after 6 months, they can get some research position, or from industrial side, or from the university. So it's a very good experience, but I'm not going to encourage you go to Aalto or any foreign university, but I say that, you know, it's a good experience to spend sometimes abroad to get some different, actually at least some different experience, and then return back to build your country. So anyway, this university, I mean, is a combination of the 3 main university. Helsinki University of Technology is one of the oldest university in Finland. So it was from 1849, and then University of Art and Design, Helsinki, so 1879, and Helsinki School of Economics, 1911. So in 2010, the government decided to build or merge them and build a new university, call it Aalto University. Aalto is the name of architect, something like this, Alvaro Aalto. So he did lots of strange things that nobody knows why. For example, we have a building in our campus. It has more than several hundred windows, but the size of windows are completely different. So you cannot find two windows, and I don't know what is the benefit, but they have this such a structure. So then we have actually totally, we are close to 200 students, 20,000 students and staff and faculties. So it's a very diverse, if you see at the beginning of my presentation, we have this color, and this is the color for department of, School of Electrical Engineering. We have, for example, computer science is white color. So if you look at this student in the beginning of the semester, when I start my work at Aalto University, I saw that they have some colorful clothes that I thought that they are technician and working somewhere, but this is representative of the department, and this is like a form class for them, and the message is that we are engineer, we should work in industry. So anyway, the number of PhD students graduate in the university normally is 210, and master 2,000 and bachelor 1,500. So assuming that you are living in the country, you have 13 university, which 4 or 5 of them have the electrical engineering, and then this is the number of PhD students graduated from the university and go to the industry. So it means that it is not enough. So I can just say that they have high demand to attract talented students, and one first message that university at the first week told me that if you are going to hire someone in the interview, you try to understand that if he or she is interested to stay in Finland after graduation or not, because for them it's very important to have these resources and work for the society. So I'm going to say that if your concern is to stay in the country, after sometimes you get the enough experience from university and industry, and then return back to India or stay there for longer time, they have a good possibility. So this is the ranking of the university, number 1 in Finland, but number 1 in Finland is different from number 1 in India, because Finland doesn't have too much university, so it is not something extraordinary, but we try to be at least, the target of the university is to be a top 50 university in the world, and they are working very well in the quality of the teaching and research. So in 2024, the ranking was 113, and we have other ranking, but we are not trusting to that one. So we have 6 schools, so we had 3 university, and they merged, so one of them was Helsinki University of Technology, and then the other 2 universities regarding the art and design. going to give some idea about that, if later someone asks that, what is the rate of the power for each residential building, normally 6 kilowatt can be enough. Okay, 6 kilowatt. Yes. So it can be roughly 17 building can be supplied by 100. 102 is exact. If they use the nominal power. So anyway, if you see in this technology, it means that Edison models could be somehow useful for some small community. So it could not actually supply the one shopping center or this type of things. And the other problem was that, not problem, I don't know if it's problem or not, but it was DC. Is it good or bad? Here said that, okay, loads were incandescent lamp and possibly DC motor. So it means that there is no opportunity for AC model because that time we didn't have DC-AC converter, even we didn't have DC technology. By the way, do you know that this Millennium Prize awarded to Indian professor in Finland because he was the person developed IGBT? Probably, yeah, this is end of 2024. I forget the name, but he was from the North Carolina, and he came to also Finland. Anyway, so we didn't have converter to convert AC to DC. So it seems that only you could supply the DC load. So it was not somehow good. And the other was that it was a small power plant. So, and the other problem was no voltage transformer. You had 110. So if you want, if not, we have no possibility for you. And the other thing is that it was no transmission line for that one. It means that you should build this generator close to the load center. So no opportunity to go out of the city and provide the electricity and distribute between by transmission line and then distribution. And so this is another problem. And okay, that's enough. We have too much problem, seems, yeah? So, okay. But the other side, we had the Nikola Tesla close to the Niagara Falls, and he used actually this hydro technology and provide the AC power. So it was a large power plant. It had actually 38 generator, which provide the 65 kilovolt ampere, 65,000 kilovolt ampere, and the voltage was quite high. So it means that the current goes down and you could transfer for the longer duration, and it was also three-phase, so you could use for AC motor and this type of devices that need high power also. So interesting topic. So if now I ask Abby, which one do you prefer? What do you see? Which one is better? Which model, Nikola Tesla's model is better or Edison's model? Tesla's model, exactly. Yeah. So we have a plenty of good reason that Edison model doesn't have. So then seems that Edison is guilty and is failed. So just close this part and said that we have Nikola Tesla. Then by this we see that from 1880 up to 2000, power can only be supplied nearby loads for the Edison model. So if we get back to Edison model. And then we need a small generation close to the load center, which needs the space, provide some noise, and lots of other things. So, and it was also suitable for the DC, assuming that, you know, we have such a problem here. Then nowadays we have the DC actually AC converter, but that time it was not suitable, also could not be transferred to other voltage, it is not flexible, and we need to actually provide the lots of generation, so it was somehow costly, and it was not efficient because we used the cool fire power. Actually, this type of cool fire power plant was not that much efficient, so but hydroelectric was good, and no suitable for induction motor. It was DC, so seems that it was not good generation. So now we get back to the traditional technology for the grid. So we have actually generation, transmission, and distribution. Am I right? So we generate the electricity, increase the voltage level, and transfer to long distance. So why do we need increase the voltage level? So when we increase the voltage, current goes down. So, yeah, sorry? Okay, yeah, this is also, it's also written, sorry? Losses, I mean, we have a lots of reason for that one, but the main reason is the losses. So, then it is also centralized and passive architecture. So what does it mean by passive? Does anybody knows what is things? Observe the energy. Yeah, it's coming from the electric circuit. Okay? This is true also. But here means that you cannot connect something like a renewable energy to this type of actually. This is why we said that you can generate electricity, but you cannot connect because grid code doesn't let you. So this is the meaning of passive. But what you mentioned is also correct for the element. Okay? So it was extensive and very complex system because we have plenty of relay to monitor the system. Fault happening, you don't know where it's happening. You use the distance and see that, distance relay to see that, what is happening. Okay, so it is not that much easy to control it. And it has a complicated control. It means that you have one option that, generation must be more than consumption, otherwise you have outage. And not reliable enough for some application. So assuming that you have a steel company, then you have a molten actually steel goes in the direction to make something, then outage happening. You don't have outage in Finland, in India. You probably have no. You have outage in. Okay, so it means that it's not reliable, and then you cannot do anything. You have several actually, So this type of problem happening also. So it's not reliable for sensitive loads. And relatively inefficient. Why is not efficient? Because we have transmission line, we have distribution line, and always generation is far from the consumption. We have losses. Yes. Okay, this is one reason. And stability issue, also one problem. Does anybody knows that, you young, actually, gentlemen and ladies, do you know what is the meaning of the stability? What is the stability? Let's ask you. What is your name? Pachi. Prachi. Sorry, Prachi. So do you know what is the meaning of stability? Exactly, yeah. So a system is stable if the relay that we have or protection device is a very easy way to say that it doesn't react. So distribution. Yes, yeah, but I'm saying that, the stability is return back the frequency and voltage. So if something happens, for example, a fault happening, then we have the fault current is very high, voltage goes down, and the under actually nominal level, actually this voltage relay react and disconnect it. So these type of things make the system unstable. But when the system generation is less than consumption, it means that we cannot supply the loads and system will be unstable and outage happening. So unsecure. Why are conventional grid are not secure? Does anybody knows? Except that PhD student close to the graduation. Why are PhD? Why our system are not secure? Because if, for example, you have a generation, transmission, distribution, long distance, and a storm happening, a tree fall down over the transmission line, and outage happening. Okay. Mm. Mm. Yes. Yeah. This is one, and another thing is that the nature of this event is reducing the security of the system, because you have the physical transmission line, and then a storm can provide the unsecurity for that one and fault happening. So seems that this is also one problem, and always we need to balance generation and demand, otherwise we have outage, and lack of flexibility means that the system is not that much friend with the other components. So we define something and we don't need to, we cannot easily to change any component, otherwise some other issue will happen. So now we get back to the history. Do you like the Edison model or not? Edison model is close to the load center. So it means that consumption is close to generation, and you don't have any transmission and distribution line. So it means that your system has less losses and also is more secure, because when you don't have this type of transmission or distribution line, the event will not impact on it, and also it is more reliable, more efficient, more secure, more resilience, more anything you want to say. Okay? So do you believe that now Edison model is good? Who didn't like it? Abby, you didn't like it, yeah? You must buy chocolate for your answer. Okay, anyway. So it is more efficient because we don't have losses. So let's see the next one. As many a small power station needed. This is the concept of distribution. It means that if we have the Edison model, in fact, we don't need to build a new transmission line. So we can use the same one, but a small power generation can be also based on the Edison model and supply the load, because we build it close to the load center. existing grid present issue with the DC loads because they are AC, or to operate induction motors at different speed. So Edison system suitable for such loads, and also we can say that because the nature of the Edison model is DC, so we can directly supply the load. And do you know how many DC load do we have in residential building? Mm. So we have light, yeah, we have television, we have laptop, we have, yeah. You see that, the number of DC loads now is more than the AC loads. So it is much more efficient if we provide DC instead of AC. So we have now this power electronics. So we can easily change from the DC to AC with different levels. So this flexibility problem is not existed anymore. And cost is somehow much more better than AC. Why? Because we don't need to build the transmission and distribution line. So we don't need to pay $80,000 per meter to build this type of new grid. So, and we also can use renewable energy sources for that one, and it can also integrate energy storage. So now we get back to the first question, that if we have a line which can supply power for 500,000, so what can we do? What is the answer? We use the small scale power generation close to the load center. And some of you said that we can use the PV, but with the Edison model also we can use also renewable energy, storage devices, and when the generation is more than load, we can supply the storage, and during the night we can use it. Okay? So this is one solution. So now if we get back to the energy flow in USA, you see that, in 2002, most of the actually electricity are coming from the coal-fired power plant, natural gas, and nuclear power plant. But if you go to 2010, you see that this new generation of the electricity from solar, from wind is increasing, and when we reach to 2016, we see that this share of the this renewable energy increase more and more. So this type of technology are very important for us. Why? Because they are renewable. They don't have any actually limitation for the consumption. They can actually, you can get the electricity for sun, and it doesn't provide any. It is like an unlimited source of energy. It's not like oil and gas. And the other is environmental friendly, and it can actually reduce the greenhouse gas emission. And but they have also some problems. So what is the problem? You cannot predict it. They are not actually constant. They are variable actually. So you cannot provide electricity from wind and say that directly I can connect it to the load, because the speed of the wind is not constant. So you cannot provide the electricity with 50 hertz and 400 volt. This type of problem is appearing. And the other problem, I don't know. So the other problem is that we are using the power electronic converter to provide the electricity from renewable energy sources. This type of actually conversion devices cannot provide kinetic energy, which keep the stability of the grid. So I will come here. Yeah. So When we provide the electricity, then we should provide kinetic energy. Okay, can I touch you? Okay, not very far. Okay, so look at him. Doesn't happen. So you touch me. Look, my inertia is less than his inertia. He's very strong. So thank you. Yeah. So the power that he has is more than me. It means that grid, when we have more inertia, it provides more reliability and stability for the network. So from where it's coming from the rotation, actual shaft of the synchronous generator. But this type of actually power electronic devices cannot provide it. So then we increase the number of the generation, but the inertia of the system will not be provided. And then we say that our grid, after 30% of the generation, exceed more than 30 of the actually generation by this type of renewable energy sources, then the system will be somehow unstable. It means that any fault happening or disturbance happening, then grid swing very badly. I mean, the frequency is not actually damping these changes very fast. So we say that our network is low inertia. So low inertia means that it doesn't have enough power to damp the changes. So for this case, this is something that we should consider. Beside that, we need the land which should use. So for example, in the city center of the Warangal, you can make the power plant. So you need the land, and it also provides the damage actually some part of the natural wildlife, and also public health and community is also affected because it makes, for example, wind provide the noises, and they use water, and after life cycle when you actually, it provides some emission. So they have some negative impacts, but what we get is very important because after 5 years, rest of electricity, the different countries have the different factors, but normally they said that after 5 years, any electricity provided by solar will be free, and you just pay for the maintenance cost. So it is very important that we consider this type of technology for several aspects, but one important thing is that, we can provide electricity without providing greenhouse gas emission. Any questions so far? No? Okay, good. Yes? Mm-hmm. Yeah, of course, we have, we can provide the, for example, wind also. Yeah, in the load side, yeah, it can be also, there is some package that can provide 2 kilowatt power by wind. Yeah. So I'm not sure that I get your question well or not. Yeah, they have actually, but later we see that we have the different size. But the problem with the solar is that you need lots of surface to provide the solar, but you can install it everywhere. But the wind is more power can be generated, but the place that you can install the PV most of the time is not good for the solar. Sorry, for the wind. Yeah. They have actually criteria for provision of the electricity. The limitation is that if you are going to provide the electricity by wind, the speed should be at least 3 meter per second. Yeah. Uh, I mean, there are lots of limitations. It depends where you're going to install your PV panel, wind turbine. So if you don't have wind, I mean, the first assumption is that you should have the place that have a potential for the wind. So if you don't have wind, it means that there is no make sense actually. But then you can not say that, you know, because we have the torque. And then if we increase the pressure to the shaft, then it will be actually explode. So these type of things are appeared, but basically you cannot, for example, you go to supermarket, you can go by truck and you go by small Peugeot. Both of them are possible, but truck is not the car to go supermarket. So you should consider that what is the optimum operation for this one. It makes sense for you. But in some cases, for example, if you have a building, like a strategic building, I don't know, you are going to measure the temperature in some place that this building is needed. So you have two options. First, that you make the transmission because the building is needed, I mean, some electricity is needed for that one. So you can ask from the TSO to make the transmission line and then distribution line to transfer electricity to that place for one building or one community, small community. And another is that you use this wind turbine to provide the electricity for that one. Which one makes more sense for you? Do you have any idea? So you spend millions of dollars to make electricity for single life, a single building. So it doesn't make sense. So this type of technology provides some limitation, but also you should consider where you are going to use. Yeah. So any other question? I think your lunch was very good. Seems that you're getting sleepy. It doesn't work by this way. Yeah, when you don't say anything, I get stressed because it has two messages for me. You are a very good teacher, we understand very well, and you're a very bad teacher, we don't understand anything. So, yes? You said yes. You're baddest. Okay. Anyway. So, we are going to work together 2 weeks, so don't be shy and easily you can interrupt me. Yeah. So, it seems that, yeah. Mm-hmm. Yes. 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 Should I explain all the? No, I mean basically, yeah. Basically, we provide the inertia from the storage devices. So we use the storage to provide the inertia. So it means that basically they said that when you increase 10% share of energy from renewable energies, you should provide 1.5% kinetic energy to keep the system balance, I mean stable. So it means that if you are going to, for example, you have 100 kilowatt, then if you are going to increase 10%, I mean assuming 10 kilowatt, so you should provide 11.5, so 10 kilowatt electricity and 1.5 for the kinetic energy. And this kinetic energy is coming from the storage devices. But later we see that we can use the model of the synchronous generator and provide the actual inertia from that. You want me to write the equation like this type of things? If you want, I can. but it's a little bit soon. So, any question? No. Good. You're comfortable, sir? You want coffee or? Okay. No, we are friends, don't worry. Okay. So, now if you get back the question, did you get the answer for the question that we discussed before the lunch? How you can provide the electricity? Do you need to build a new transmission and distribution line, or you can use the local power generation? Yeah, one aspect, actually, this is not the only way, but you can also optimize the energy consumption. So, for example, instead of have the conventional thermostat for the fridge, you can actually provide the somehow program microcontroller and provide a smart control in fridge. So just give one example. So in normal situation, you have the conventional actually fridge. You see that the temperature is 2. And if it is 8 a.m., temperature is 2. If 1 p.m. is 2. I don't know, 8 p.m. is 2. And 3 midnight is also 2. Am I right? So then the problem is that we normally are in off-peak, for example, 6 a.m. We don't have too much loads. So stress over the grid is very low. And but 10 a.m., you see that lots of the companies are working and people are working with the computer in the office, and lots of other business are active, and we need lots of electricity. So it means that we are in the peak time, which stress over the grid is high. Don't worry, I'm making a joke. Then Arya, explain what did I say? Why? Okay, go and wash your face and return back. Okay, then when we reach in this time, you pay 2 times more and you increase the stress over the grid. So it is not very good from the grid perspective and from the customer perspective. Okay? So what should I do? I said that, for example, between 8 to 10 or 8 to 12, we are in on-peak. We don't, yeah. Okay. Okay. So assuming that between 1 a.m. up to 8 a.m., we are in off-peak. And from 8 a.m. up to 10 a.m., we are on peak. Okay? So I program my fridge in a way to say that, if this is 2 degree optimum degree that I need, so I said that, okay, reduce the temperature to, I don't know, -1 when we get close to 8. Okay? So, and also increase the temperature in a state of 2 to 3. Okay? So put the set point in the temperature of the fridge. So what happened? When we reach 8 a.m., the fridge will be off. Okay? Off. Then the temperature increase is coming to 2, but nothing happened because we increased the temperature degree, set point to 3. So it goes to 3. Okay? So it goes from -1 to 3 in the state of having always in 2. So from this time, 8 a.m. up to 9 a.m., 1 hour, nothing happened. Your device is off. Okay? So then we pass the 9 a.m. Now we see that, because the temperature exceed 3 degrees, then the fridge is now on. So in this on peak, we easily could actually turn off without making any problem for the consumer. So this is something that we should consider. One, minimize the consumption. We call it smart load, and you have a lots of actually technique that optimize, and it is not complicated at all. And other is that using the local power generation. So it means that we reduce stress over the grid during the peak time, and also the customer point of view is that you don't pay or you don't buy electricity during the time which the price is high. So now, do we need to build another grid? Probably no. Or we can prolong it, because after that, if you maximize the or minimize the consumption, then you can reduce 10%, and you can also increase the share of the local power generation, but it is not still enough. Then you should find a better solution. But meantime, this is actually good solution for that one. So instead of after 10 years you build another grid, probably you need 20 years. Any questions so far? Good. So you don't shy, actually. You're bachelor, and then if something is a little bit probably need more, because you hear lots of things about the system. I don't know, smart grid, microgrid, but if you don't understand, tell me, I can actually explain. So, and now we have the concept availability. Availability means that how much your system is secure or available. So if you have actually some source of energy just based on the PV, and it's just can provide the electricity when you have 8 hours or 20 hours or 12 hours PV, it means that for 12 hours your availability is 50%. Am I right, Arya? Okay, welcome back. Okay, good. So the concept of the availability is also somehow linked with the resiliency. Does anybody know what is the resiliency? Probably you heard resilience grid, resilience building, resilience system, but nobody knows what is the resiliency. Do you know? Yes? Do you have any idea about the resiliency? Okay, so let me explain to you. So assuming that you have a PV and does anybody wants to say something? Okay. You have a PV, you have a battery in your home, and a storm happened, and you have outage. Then you said that I have a battery that can provide the electricity for me during the night for 3 hours. So it means that you have available electricity for 3 hours when the grid is off. So it means that you have a resilience grid. But then they are switched at how much this resiliency is available. So this is important. In some cases, actually, you said that, when you have a outage, it means that your system is not reliable. It is true. But it depended how long you have electricity and or also outage. So when we are talking about a reliability, and when we said that the system is not reliable, it means that some peak time we have a stress over the grid, and for short time you see that you have actually flicker or this type of things that seems like a disturbance, and the system is not reliable. But when we are talking about the resilience, it means that we don't have for the longer duration. Okay? So when we are talking several hours, it means that resilient system. So is it clear for you? Arya? Good. Did you eat good lunch? You say, yes. Yeah, okay, good. So this is the problem if I memorize the name and then I can easily, hey, yeah, this is target student. Okay. So now we get back to the grid. And conventional US grid availability is normally 99.9% reliable or available. So is it good or bad? Good. So, Sami, you're sleeping? Okay, so what did I say? Hmm? So is it good or bad? Okay, so no, I'm saying 99.9 is good or bad? Good. Any other idea? We must buy chocolate for next session. Yeah. So, no. You just say yes because of this, no because of this. So, Costa, do you have any idea? Is good or bad? 99.9%. And it's good if we have 80%, yeah? Okay. But when we say 99%, 99.9%, so it means that 0.1% actually we have possibility for outage. So is it good or bad? I mean, it can happen. So you cannot actually, I can say that when I'm coming here, it's probably, you know that the flight, each 1,200,000 flight, one of them fall down. Okay, so I have the possibility to, okay, so, but I can make this risk. So this 99.9 is good or bad? Tell me. You can make the risk and make the this heart operation by this? No. So it's not good. 99, even 99.9% is not good for the reliability. So what we need is 99.999. Why? Because we cannot say 100%. And it's not coming, this reliability, from conventional grid. Why? Because we have a lot of things in the power grid that can affect the other parts. So for example, a storm happening, one part, and you have actually the impacts to the other parts, because they are actually transmission lines for the long distance, and then this, it makes the system unreliable. So for example, if you get back to this, you see that a storm happened here, but we don't have electricity here. So it is very unreliable technology if you're going to make this some sensitive work and rely on this type of 99.9% reliable electricity sources. Okay? Because as long as we are caring about the human life, we cannot make any risk. So this is actually something that when we said that 99.999 is like that flight, each 1,200,000, one of them actually fall down. Yeah, Arya, do you have something? No. Okay. Yeah, and you know that this is one of the top 10 hard dying method, falling from the actually this. Yeah. Okay. So for this case, we see that now the model that we had from the Edison seems that it's not that much bad. Okay, so we didn't have transmission line, distribution line. It's close to the load center, so it is more secure. You can provide the electricity here and then do the operation here. Okay, so it means that it is more secure than the transmission line or normal grid. So look at this one. Yeah. So this can easily happening. So this is very normal in Finland. So this is why they decided to have more underground, line. And if you see in the street, you cannot find too much actually this overhead line. And this one is also, I think that normal in the warm place. I'm not sure in India, but if you go to some part of the touristic place in Turkey, you easily see that, hundreds balloon over the sky. Yeah, this can easily happening. So if we get back, what we do by Nikola Tesla doesn't have such a problem, but by Edison. But what developed by Nikola Tesla has this problem. So the other part is the cost. So in Tesla's model, we need providing the substation, transmission, distribution, transformer, lots of conversion devices, but we see that, here we don't need, we provide the electricity and use it. So it is not that much from here. You can use the roof or something like this, so it's much more better. And other issues with the conventional grid. It is not that much easy to interact with the new technology, like renewable energy sources. And also, it has stability problem, because we always need to provide the electricity more than the consumption, and we don't have actually too much for the flexibility because they are passive network, and we cannot actually integrate renewable energy sources based on the So I'm sorry if I'm pronouncing wrong. Honestly, tell me that why it is not flexible, why we cannot connect renewable energy to the power grid, conventional power grid. You have two options. Answer my question, I buy chocolate for all the class next session. So, yeah, why? Inertia cannot be provided, then, okay. So, why we cannot? She's going to suicide. I give the answer, she doesn't, so you're going to buy actually chocolate. Okay, tell me, why we cannot? Inertia cannot be provided. Exactly, yeah. So, the reason is that, thank you. This type of generators, they have some unpredictable dynamic behavior, can provide some disturbance for the grid, and they cannot provide the inertia for the grid. So if we increase such a generation more than 30%, then grid will be unstable. So this is why the grid code is defined in a way that you cannot integrate new generation or new types of the generation with the conventional grid. Thank you again. Okay. So, next, the grid user is a passive participant where he or she likes it or not. It means that although you can provide electricity for yourself, you cannot provide or inject to the grid. I was watching a video from a presentation, so it is not my word. This is exactly transfer of his. They said that it is like a marijuana. You can plant for yourself, but you cannot sell it for the others. Yeah. So you can electricity and use it, but you cannot sell it to the grid. So it is why they said that this is like a passive participant. And the grid is old, so the power plant is normally more than 30, so it is not compatible with the new technology. And also, beside all of these things, we have the other thing about the sustainability, availability, I don't know, cost, about the what we discuss, security and this type of issues. But the good news is that conventional power grids are extremely strong. So it is not that much sensitive. But another bad news is that now we are not living in the Edison or Tesla's duration. Technology is changing, network is changing, and we need to upgrade our system. So for this case, the technology which is connected to the power grid are not something that we use 25 or 30 years ago, or I don't know, 100 years ago. So for this case, we should provide the solution for that one. And now, what is the solution? Distributed generation technologies. This is what we are going to provide as actually solution for the jumping between the old time to modern time. So, up to now. Does anybody has any question? What? This flexibility. Which one? Yeah, it's some things that, yeah, no, basically is about the, this type of interacting with the renewable, and because when we are talking about operation is in a distribution level, and when we are talking about distribution level, that impacts is the local power generation, which is not that much easy to interact with this. But this is the technology that after 2000 is growing so fast. So if we are going to consider old version of the grid, it is not somehow basically, when we are talking about the renewable energies, we have two types. It can be a smaller scale, less than 10 megawatt, or more than 10 megawatt. Less than 10 megawatt is distributed generation, which is distribution level. But after 10 megawatt is the power plant that can be in transmission line. Yeah. So it depends on where you are going to consider. But when we are talking about the transmission line, then we have also some other constraints. So this is why now we are considering the concept of the grid forming converters, because grid forming converters can be like a voltage source that act like a master. So it can provide the reference for the other sources. But then it cannot be, it can be basically for the power plant. If you have, I don't know, 1,000 units for the PV, then it should act like a grid forming to provide the stable operating condition as a power plant. But when we go the a smaller unit, less than 10 megawatt, it is between 1 kilowatt up to 10 megawatt is a distributed generation sources. So then it has the different aspect that you consider the interaction with the distribution grid. But in power plant, you should consider the inertia of the transmission grid. This is also some other problem. Because when we are talking about the penetration of the renewable energy, it doesn't mean that local power generation. You go power plant level. So, any other question, Arya? You okay? No sleeping more? Yeah. You want me to give the break? You have a take a nap? Actually? No? It's good? Okay. No, don't worry. Any question from you is lovely, actually. Tell me.
No. So like actually, I used to get this thought in like when I was in my childhood, kind of. So like I had interest in solar energy. So like there is in Thar Desert region in India. Like, I'm not sure you know about it or not. So
How
like,
do you know?
It is in Rajasthan. So like it is full of like as it is a desert region, it is full of sand and mostly whole of the year there is sunlight. So like. Can there be like we can build a system like that? Like we cover whole Thar desert region, or maybe 50% of the region or 70% of the region, and then whatever the electricity is generated, transmit it to whole of India or maybe the whole of state, depending on whatever amount of electricity is generated.
Yes. I mean, this is we say actually this is some private company take care of such a generation. And it depends, but normally it's not very high level. So what happens? So assuming that you have such a potential and you provide electricity, then the owner of this small power plant provide the commitment with or make a deal with the distribution company. So distribution company, they said, okay, this is the profile that I can sell to customer. And distribution company said, okay, thank you very much, I buy these things. But can you guarantee it? Today is sunny, tomorrow can be storm, for example. So then you promise to distribution grid, and distribution grid also, distribution company promise to the customer. So if you didn't respect to your commitment, in fact, outage happening. So do you have any idea about this? What should we do? Okay. Does anybody has any idea? So assuming that I have a solar farm, I can provide the electricity and then provide this forecast to distribution company, but if I cannot provide the electricity, then distribution company cannot provide the electricity for the customer. So what should we do? This is the real case, but there are solutions for that one. So anybody wants to buy chocolate? No, wants to get chocolate? No? Battery is one option. Yeah. But let me explain you. Diesel generator. Okay. But what is the benefit for you as a seller?
Because some critical loads is there.
No, I'm talking with the distribution company. I don't know what kinds of loads are appearing the others. Okay, let me tell you something. If you get back, I mean, today is the temperature is, do you have any idea what temperature today? 24. So if you get back last year in this time, what was the temperature? Yeah, something like 25, 23, and the weather is quite similar, yeah? So if you get back 5 years ago, it was not -3. -3, okay? It's like a 20, 21, or it's a little bit similar. So they check the radiation for the last 5 years, and then based on that, they can guess that, okay, next year will be something between this to this. So for this case, they provide a commitment that this is based on the forecast of the radiation, my generation profile. So when you provide this generation and then say that, okay, but I probably can go up to 10% more or 5% less. Then distribution company accepted, but said that if you could not meet your commitment, you should pay the penalty 10 times more. So for this case, they buy a storage, and if we have actually some gap between what we promised, yeah, then they use the storage devices for that one. So this type of a small, actually, when you see the, I don't know, in the India is popular, but if you go to southern part of the Europe, Spain, Portugal, in this type of, they have actually private sector that they provide the electricity based on the forecast and sell it to the distribution. And what is the benefit for distribution company? They don't need to provide the power plant, transmit, and then so it's somehow a benefit for them. Yeah. So, any other question? Udaya, do you have any question? Yeah, actually the most famous one is the Abengoa, which they made the this biggest thermosolar power plant actually in Atacama Desert. It has the biggest radiation level in Chile, and it was during the President Obama time that Obama also, they had some project also in California and this Nevada desert. So yeah, this is very famous for the solar. Your friend also worked there, Pedro Rodriguez. Endesa, yeah, Endesa is one of them, and I also have one video that from Endesa, so I can show you. Yeah. So they have actually this axion, they have gamma, and you know that. So if we are talking about Spain, the first things come in your mind. What is the first things in your mind? That, you know, bullfighting, football, salsa, this type of things. Yeah. Do you know that two of the top best wind actually company are located in Spain? So they have actually very strong industrial sectors, but also very good actually bullfighting and this type of. Have you ever had such an experience, this bullfighting? You had also, yeah. You were in the arena of Barcelona. Ah, okay, yeah, yeah. I have a video I can show you later, probably. I can find it. No, I cannot because it's in external. So I was in the La Liga and Messi was like 2 meters far from me. And actually I didn't know that he's Messi. Anyway, I remember that when I got the position in UPC, Polytechnic Barcelona, and then I got also Polytechnic Madrid, one PhD position there. Then my cousin actually, he said that you must go to Barcelona. And then I said, okay, so you have no idea about the electric? No. Although Madrid is good, Barcelona is something else. And he was just talking about the football club. Yeah, but it's a really, really good experience. So, Udaya, you want to have a break, or because I'm going to start the second chapter, so, and you're going to teach, or I should continue? I mean, it's totally up to you, yeah. Yeah. Okay. So, yeah, no, it's fine for me, but I decided, you know.
Yeah. So what we can do that we'll take break for the tea. After the break, that you can go to your hostel rooms and the research will start.
So, see you tomorrow, and if you have delay, you must buy the chocolate, okay?